Hi, this is Ruoxiao and Qinyan. Our project is about newsgroup classification. We consider to do this because we are living in an era with flood of information, and thousands of news is posted every day. It is almost impossible to read every piece of news, and most people choose to just read those they are interested in. Thus, it is very helpful to classify the news and give a label to each piece, such as politics, sports, etc. It helps people to save a lot of time deciding which news to read and improve the efficiency to find some certain news. So what we want to do is to train the model to identify what category a random piece of news should be in. And the machine learning technique we use is naive Bayes. The feature we want to use is a keyword. We consider news in different categories will have different types of words that are mentioned frequently. So we made a word list which includes the word appears in at least 2 pieces of news, and then we count the number of times that each word appears in news under a given label, and this is the numerator of the naive Bayes calculation. Then we count the number of labels of each category, which is the denominator. We compare the likelihood of each category and predict the outcome with the maximum likelihood.
Our data source is the famous 20 newsgroup dataset. This dataset is a collection of approximately 20,000 newsgroup documents, partitioned evenly across 20 different newsgroups, each corresponding to a different topic. Some of the newsgroups are very closely related to each other, while others are highly unrelated. For data processing, we first load data using sklearn, which can load the dataset conveniently and provides useful tools to do basic data pre-processing. While load the data, we choose to use part of them and reclassify the data into 6 large groups: computer, vehicle, sports, science, religion, and politics. To guarantee roughly an even amount of data for each group, we retained around 1,200 pieces each group, which is around 7,000 in total as the training set, and 400 each group, around 2,400 in total as the test set. And sklearn helps to give labels and remove headers and footers, leave us the main body part. Since we want to use the frequency of words as features to do the naive Bayes classification, we remove the special characters and write all processed documents and their labels accordingly into a new file for later use. However, the result is not satisfying. We doubt it is the data preprocessing part that has potential problems. Words in the content are in different forms. Change of part of speech or tense can change how the word looks, even though the meaning and stem isn't changed. So we redo the text normalization, change all to lower cases. All numbers in the text are replaced by the word number, and did canonicalization, which includes only extract word stem, and lemmatization with the help of NLTK, a leading platform for building Python programs to work with human language data. This plot shows the validation error with different threshold of the word list. We found when t equals to 24 and 25, the error rate is the lowest. So we then apply this to the test data, and the error rate is about 28%. The reason why the final result is still with a rather high error rate, we think, is about the features and algorithms. Many more meaningful features can help to improve the performance. Thus, further improvement may include using more training data to generate and include more features, as the feature extraction provided by sklearn can exceed 30,000 with all 20 newsgroups data. And in later research, we also found that people had used many different algorithms to do this classification, and the multinomial naive Bayes provided in sklearn is actually one of those with lower accuracy, not to mention the one written by us. And some better performance algorithms like decision tree classifier can reach over 97% accuracy. And here's the reference, and that's all. Thank you.